So before we begin, all of you have used apps like Swiggy, Uber, Zomato. The fundamental concept of using these apps is your location. Without the ability to showcase your location, none of these apps would have been possible, and none of the revolution of generating so much of revenue as well as jobs using these concepts would not have been possible. All of us have been using these apps without understanding what is the fundamental nature of these apps or what are the fundamental things used in this app. In one short sentence, if I have to say, the fundamental for any of these apps is your location. These apps are able to capture your location, at the same time propagate this location to their system. For example, if you take a ride aggregation company like Ola or Uber, they're able to capture your location, and then they're able to share your location with the cab drivers, and based on the distance, based on the availability, the cab is assigned, and you're also able to see how that cab is moving towards your house. Gone were the days where we have to call a cab company and then tell them, this is my particular address. There is a landmark here. You take a right at this particular school, take a left at this particular milk booth, and then come near this park, and then you'll find my house. Every time it leads to confusions, and you are not aware in real time whether the driver has started or is still at home. So all these things, the problems have been mitigated, and just as a click of a button, you are now able to experience the power of location technology. And the fundamental technology that is powering location analytics is your geographic information system. So let us understand some of these things in detail. So today I'll be covering a very basic introduction to the topic. Then I will give you some fundamentals in this field so that tomorrow, if somebody who has attended this seminar, if somebody talks about GIS, you will at least understand some of the terms that they are using. You will also understand how this technology is powering various other fields. Then we will look at what exactly is this GIS. Then I'm going to show you a very interesting case study, how GIS has been used in real estate. It's a real world case study. And finally, what are the career opportunities? What are the job prospects? All these things we'll be seeing one by one. So let us go to the introduction. So I'm going to start with a very fundamental concept of what is a map. All of us have learned about maps right from our school, right? We have learned about mapping in geography classes. I, in fact, remember in our 9th standard, 10th standard, we are asked to draw a particular map of a state or map of India and then label some of the important places like some rivers, some important places where some battles happened. So we have all been used to working with maps. But let us understand the fundamental concept. What is a map? So to simply put it, map is a symbolic representation of any geographic phenomenon. So what does that mean? Geographic phenomenon can be anything. It can be a lake, it can be countries, it can be continents, it can even be the surface of the moon. Now that with the ISRO's Chandrayaan, we are also getting data of the moon. Now if you are able to map it and show it to people, that is also a map. So map is basically a symbolic representation of any geographic phenomenon. Now when we take any map, for example, it can be a map of Karnataka, it can be a map showing all the states of India, it can be a map showing all the rivers of India, it can be a map showing the continents. Any map that you take is fundamentally composed of three things. Just like if I have to speak in a particular language, say I have to speak in English, the first thing that I need to know is alphabets. Once I know alphabets, I can then form words. From words, I can form sentences, and from sentences, I can start speaking in an easy manner. Similarly, just like alphabets are the fundamental for any language, for any map, the three fundamental things are points, lines, and areas. Now, for any kind of map preparation, you need to clearly understand what is a point, what is a line, and what is an area, and to when to use them. Once you understand this, I would say any kind of map you are asked to prepare, you will be able to prepare with much more efficiency and with much more effectiveness. So let us understand these three things in full detail. Now to understand the concept of points, let me just share my another screen. I'm going to go to a popular software called Google Earth. All of you have been using the software called Google Earth. Now our entire Earth has been divided in the form of latitudes and longitudes. I'm sure you learned this in your school as well. And the very fundamental concept is, if I have to locate something onto the earth, I can use the concept of latitude and longitude and locate that particular point. And again, you need to clearly understand these latitudes and longitudes lines are not real lines. They are imaginary lines. That is, for example, if you go outside and if you stand on the road, you don't see these lines in a physical manner, but these are imaginary lines which help us to understand more information about a location, mainly pinpoint a particular location. Now, let me just zoom into a particular area. Let me just go to Hulsoor in Bangalore. I'm just moving to Hulsoor. So now it is just zooming to that particular place. Now please understand the concept of point. Now see the latitude and longitude, the grid is visible. Now I'm just going to take a particular point data like this. Please see my screen. At this particular point, the latitude and longitude, please see this, the latitude and longitude is 12 degrees 58 minutes 42.72 and longitude is 77 degrees 37 minutes 43.67. Now, the any point on the earth is given by a unique set of latitude and longitude. In no point wherever you see on the earth, you will have the same latitude and longitude repeating. That means any slight movement, I get a new set of latitude and longitude. So please see this. At this point, the values are 42.72 and 43.67. If I slightly move it to this particular point, you can see the change. Can you see this? 42.39 and 53.01. So like this, even a very small change will lead to a different latitude and longitude. So like this, wherever you move, you will have a different latitude, longitude. Now, if I just zoom out and if I go to some other place, the latitude and longitude will vary by a larger extent. See this? Now from 13, it has moved to 14. Similarly, if I move away from India and if I go to some other place, for example, I'm just moving this from India to some other place and automatically the latitude and longitude is also varying. So this is the fundamental concept that is used in all these apps. Your location is always unique. So when you book a cab or when you order for a food delivery, your location is automatically picked by a GPS in your phone, and based on that your location is displayed, and to this particular location the cab is being sent or the food order is being delivered. So in essence, I want you to understand the concept of point. It is nothing but a unique set of latitude and longitude. So let me go back to the presentation now. A unique set of latitude and longitude is a point. Yeah. So we can represent various real world features in the form of point. For example, if there is a tree in this particular park, please see my screen, there is a tree in this particular park. I can represent this particular point as a tree. I can also represent other things like a traffic accident. In the place where there's a traffic accident has taken place, that can be represented as a point. A lamp post can be represented as a point. A building can be represented as a point. So anything that has a single latitude and longitude, geographic coordinate means anything that has a single latitude and longitude is a point feature. So like this, any world feature where it has a single location, I can represent it as a point feature. Now let us come to the line feature. Now this is a line feature. So please see this red color line. Line is nothing but a series of points that are joined together. So I start from a point and then go to the next point and then go to the next point, and then end at a particular point. So line is also a series of points, but the first point and the last point, they are all joined. From the first point to the last point, it is joined by a single line. So in the real world, what can I represent as a line? So in the real world, I can use roads, I can use streams, I can use railways, I can use canals. So anything that is a linear feature, anything that has a length can be represented as a line feature. So that is the advantage of representing it as a line feature. Now third, let us come to the third feature. It is called the polygon or the area feature. So in the area feature also, I start at a point, go to a point, go to a point, go to a point, and then go back and end at the same point. So a polygon is nothing but a series of points where the first point and the last point are coincident. Coincident means what? The point lies exactly on top of the other. So that is the meaning of coincident. So any closed figure is a polygon feature. So now what all in the real world can I represent as a polygon feature? I can represent lakes, I can represent soil types, land parcels, anything that has an area, I can represent it as a polygon feature. So now if you have understood the difference between point, line and polygon, you will be able to represent anything in the world as a combination of these three things. Now let me take an example. If I want to create a map showing all the metro stations and the metro lines of Bangalore. So if that is my project, then what should I use? To represent all the metro stations, I can use points, and to represent the metro line, the purple line and the green line, I am going to use lines, right? So using a combination of points, polygons and lines, I'll be able to represent anything in the world or even outside to show it on a map. So that is the fundamental concept. Hope you would have understood the difference between point, line, polygon and how and where to use them. Now I'll give you one more example of understanding points, lines and polygons. Now your college management comes and tells you, now that you have done a webinar on GIS, I want you to map our entire college campus, right? So the challenge for you is to map your entire college campus. Obviously your college campus consists of buildings, various departments, and there are roads to go from one department to another department. There is your ground, there is the administrative block, there is your library, there is your canteen. So the college management is asking you to map all these things together into a single map. So now you will have to decide what to use as a point, what to use as a line, and what to use as a polygon. So to map something like a building, I'm going to use it as a polygon so that I can say this is civil engineering department, this is computer science department. And to map something like the roads, so from one department to another department, I can use the line feature. Similarly, if I have to map something like a electric pole, a street pole, or a tree within the campus, then I'm going to use the point feature. See, now I hope you're able to understand using a combination of point, line, and polygon, you can virtually represent anything that you want, right? So now to deep dive and to understand things in a much better way, let us understand the concept of map scale. Now, as civil engineers, I'm sure when you have done your CAD drawings, there was something called a scale which you mandatorily had to put it on the drawing. What is a scale? Scale is nothing but a ratio of distance on the map to the corresponding distance on the ground. Now, let us understand this in a very clear manner. Let us go back to the campus mapping example. Your college management has asked you to map the entire college. Now, if you want to map it at 1:1 scale, is it possible? 1:1 scale means what? 1 centimeter on the map equals 1 centimeter on the ground. That means if your college campus is 10 acres, assume most of the colleges are now 30 acres, 40 acres. Assume a small college with 10 acres total area. If you have to map this campus at 1:1 scale, then you will have to ask for your management, give me a paper whose size is 10 acres. Now, no way you can get a paper size whose size is as large as 10 acres. You will get a paper size of A4, A3, A2, A1, maybe A0. So you cannot map it at 1:1 scale. That means you need to reduce the scale. Reducing the scale means what? If I measure 1 centimeter on my map, that is equal to 1000 centimeters or 10,000 centimeters onto the ground. If it is 10,000 centimeters onto the ground, then I will say the scale of the map is 1:10,000. That means 1 centimeter if I measure on the map, that is equal to 10,000 actual centimeters on the ground. So that is the advantage of a scale, because you cannot represent everything at 1:1, right? Now in GIS there are two types of scales. One is called a small scale map and the other is called the large scale map. A small scale map is one wherein this is a small scale map. You are able to see the entire India. Can you see this? You're able to see entire India. Now I take only South India and I zoom it. I get only South India. I zoom it further. I get only the Chennai portion. I zoom it further and I get a small portion of Chennai. Now this particular area is a large scale map and this entire area is a small scale map. Now the difference between a small scale map and a large scale map, obviously by looking you will understand. In a large scale map, I have more details. See, I'm able to see a particular a small stream. I'm able to see the parks. I'm able to see buildings. I'm able to see roads. I'm able to see more details, but a smaller area. In a small scale map, I'm able to see a larger area. Can you see this? I'm able to see whole of India, but I don't see the buildings. I don't see the capital cities. I don't see any roads. I see only the polygons. So in a small scale map, I'll be able to see larger area, but lesser details. In a large scale map, more details, but lesser area. Now there is a common interview question, whether as a civil engineer or as a GIS person. One interview question could be between 1 is to 5,000 and 1 is to 20,000. Which is a small scale map, which is a large scale map? And they will not give you time. They will ask you immediately within 1 to 5,000 and 1 is to 20,000, which is a large scale map. If you don't know the concept, you may understand 20,000 to be a larger number. So based on that, if you say 20,000 is a larger number, then you will be wrong. So you'll have to clearly say, in a large scale map, I'm able to see more details, but at a lower area. So this is the difference between map scales. Now, how does that affect our project? Now, let me take another example. How does this exactly affect our project? Suppose now all of you know about point, line, polygon. Now the BCCI, all of you know BCCI, the Board of Control for Cricket in India, they come to you and say, I want you to map all the IPL stadiums, all the stadiums for IPL in India, right? So the task is to map all the IPL stadiums. Now you will have to decide whether you have to go for a large scale map or a small scale map. Now simply if the BCCI comes and says map all the stadiums, you can just map it as a just the points. For example, I can map in Bangalore Chinnaswamy Stadium, in Chennai Chepauk Stadium, in Delhi Firozshah Kotla Stadium. Like this, I can just map all the stadium locations as a point, and I can finish the job. However, if BCCI says, no, no, I was not meaning this one. I want you to map that entire stadium. I want you to map the pavilion. I want you to map the pitch. I want you to map each and every seat so that when people come to attend a match, I can do social distancing. I can say this particular seat, one person should sit, and then two seats apart, one more person should sit. That means I need to have a map showing the entire stadium with each and every detail. So in that sense, I cannot map the stadium as a point. I have to map the entire stadium as a polygon, and that will be a series of polygons. Every spectator seat will be represented as one polygon, and that entire thing will be a set of multiple polygons. So now do you see the difference between when to use a point, when to use a line, when to use a polygon? The answer to this is the use of point or line or polygon depends upon the purpose of the project. If you know what is the purpose of the project, then based on that you can decide. And this is not just relevant to GIS, it is relevant to any project. So tomorrow as a civil engineer, somebody asks you to construct in their particular site. Their site is 100 by 100 in dimension. They ask you to construct. Can you immediately give a quotation? What is the first thing that you will do? You will first ask them, what do you want to construct? Do you want to construct an apartment? Do you want to construct a commercial building? Do you want to construct an individual villa? Right? So based on if it is a villa, the quotation is different, timeline is different. If you want to construct a mall within that 100 by 100, quotation is different, pricing is different. So whatever project that you take, one thing that you need to remember is, first thing that you need to ask is, what is the project purpose? Based on the purpose, you can then decide whether you should go for a small scale map or a large scale map. Now, once you know this one, you have basically understood the difference between point, line, polygon, and when to use them as a point, line, or polygon. So till now, these are all the very basic fundamentals. Now let us come to the main topic of the seminar. What is this GIS? Till now, we represent about maps and point, line, polygon. Now let us understand what is GIS. Now, some of you may have taken an elective in your college, or some of you may have generally known what is GIS. So if I ask what is GIS to people, they generally say as GIS is Geographic Information System. But this Geographic Information System is just the expansion. It is like, what is UNO? UNO is United Nations Organization. That is not what it is. That is just the expansion. So you need to understand what is GIS. Now, when you come to a textbook definition of GIS, a textbook definition of GIS says GIS is a system used to create, manage, visualize, analyze data and its spatial counterpart. Very big definition. It is, I'm not able to even understand such a big definition. Now, don't worry about a textbook definition. I'm going to give you a very simple definition which will make you clearly understand what is GIS, so that even if you have to explain this to an 80-year-old person, you will say this is GIS, right? Now I'm going to tell you GIS is nothing but location plus information. Very simple. You can write it down if you want, if you have a paper and a pen with you. GIS is nothing but location plus information. Now let me give you another example to clearly understand this. Again, let me go back to cricket itself. In Bangalore, we have a stadium called Chinnaswamy Stadium. Suppose an IPL match is going to happen, and I am a fan of IPL. I want to go to this particular match to watch RCB versus say Mumbai Indians. Now I go to Chinnaswamy Stadium, I buy a ticket, I go there, and at the security entrance, he is going to check my ID. So I show my Aadhaar card, I am the person, I show the ticket, and I go and watch the match. RCB versus Mumbai Indians match was very nice, and I came back home. Now, after 6 months, Australia is coming to India and they are now going to play a test match in Bangalore. So, if they say I have to play a test match in Bangalore, there is no other stadium. It has to be again Chinnaswamy Stadium itself. Again, me being a cricket fan, again I want to go and watch the test match. Now, when I go to the Chinnaswamy Stadium and I go there, I meet the security, I show my Aadhaar card, I am the same person, location is still Chinnaswamy Stadium, but the information now is India versus Australia. Now, without the valid ticket, if I show the old IPL ticket, will they let me inside? Can I use the old IPL ticket, my Aadhaar card, and then can I go inside the stadium? No way. He will say, you are gone mad, you have got to go to Nimhans, right? He will just kick me out. I cannot argue. I cannot say I am the same person. See my Aadhaar. It is the same location. But what has changed? The information has changed. So what is this GIS? Using this GIS, we are able to model this changing information. So in the month of March, April, it is location plus information. Location is Chinnaswamy Stadium. Information is IPL match RCB versus Mumbai Indians. After 6 months, it is information is India versus Australia test match, but location is still Chinnaswamy Stadium. So what is this GIS? GIS is nothing but location plus information. You must be in a position to represent both location and the information and show the changes to both the location as well as the information. With that, I hope you get an understanding what exactly is this GIS.